Hi everyone, I'm Ji Chuanzhen from the Chinese University of Hong Kong. Here I will represent Cui Gao, Frederick Sarro, David Rowe, and Irving King, and Michael Liu to present our journal first paper, Do Users Care About Ads Performance Costs? Exploring the effects of the performance cost of in-app ads on user experience. In-app ads plays a very important role in app monetization. We can see there is a growing trend of the percentage of app with ads. For example, in 2020, there are almost 76% of the apps that has ad inside. There are four parts in app advertising ecosystem: developer, advertiser, ad network, and users. Advertiser publish their ads to ad network, and developer provide the apps and get paid from the ad network by providing the ad position. The app with ads are finally delivered to users. Users play a very essential role in ad profiting system, since the number of ads displayed to users determine the ad revenue. However, embedding ads inappropriately can ruin the user experience. According to a survey of top 7 reasons why people uninstall apps, we can see that there are almost 50% of the users that uninstall their apps because of the intrusive ads. Here we use user review for mining user experience. Because user review can generally serve as a primary channel for customers to leave feedback, and the user reviews reflects the real and immediate user response after interacting with apps. Here is an example of user review that complaining too many permissions and too many memory usage, and give 1-star rating. In this paper, we present Rank Miner, a powerful tool to mine the user reviews and rank app review issues. Rank Miner has 4 steps. The first step is the review pre-processing. We first lowercase all the characters and remove the non-English characters and non-alphabet numerics. And we do lemmatization for all the words of the user reviews. Note that here we didn't remove the stop words and the compound words and the misspelled words because these words are widely appeared in user reviews. In the second step, we use PMI to retrieve phrase. So here we have retrieved 2 types of phrase, bigram and trigram. For bigram, such as too slow network connection. For trigram, such as slower than before, 30 seconds ads. In step 3, we propose to use an effective word representation approach, that is word embedding, to discover the semantically similar words and phrases for each app issue. Here we retrieve top K terms, most close to the specific app issues, based on the cosine similarities of their vector representation. The last step is issue grading. So here we acquire the sentiment score by using the sent strength and apply our rules. We acquire the frequency score by using the number of reviews of each issue. And in our final concern score, we combine the sentiment score and the frequency score in this equation. Here we demonstrate that our proposed rank miner approach can effectively quantify user concerns about specific app issues. You can see that rank miner significantly outperforms cross miner in PCC and NDCG. And this figure shows the related terms extracted by rank miner according to the different type of issues. With the powerful tool Rank Miner, we need to answer 2 research questions. The first is, do the performance cost of in-app ads significantly increase the non-ad versions? Here we study 20 subject apps in our empirical study. For each subject app, we measured 4 types of performance cost: that is memory, CPU, network, and battery consumption, for both with ads and no ads versions. In this figure, we can find that the ad consumes a large part of the performance cost in all types of issues, especially the traffic data cost. From this figure, we can clearly find that the performance cost with ad versions are significantly larger than those of non-ad versions. So here we have answered our first research question, and our second research question is, how can the performance costs of ads affect user opinions? And we found among all the user complaints about the app issues, the complaints of ads varies from different apps. For example, in memory cost, the A2 received the most significantly complaints about the ads among all the subject apps. We further compute the Pearson correlation score and the Spearman rank correlation between the different type of user complaints and app issues. And we found that the battery issue has a higher correlation with the user complaints with a high confidence, and the network issue has the lower correlations with the user complaints. So we conclude that the user care most about the battery cost among all the performance cost types and show least sensitive to the data traffic cost of ads. To further develop what RankMiner can do, here we illustrate a bubble map of the user concern ad issues, with a large bubble size indicate that the user complained more. Here we manually categorized such ad issues into 5 categories: obstructions, ad size, ad timing, appearing style, and ad content. And we get the following insights. First, choose ad SDKs that can recommend relevant ads. The second is avoid pop-up ads. The third is avoid full-screen ads, and shorten the compulsory video ads. And this is the insight for developers. Here comes our conclusions. We propose an approach named RankMiner for quantifying user concerns about app issues. We find that the performance cost of with apps versions are significantly larger than those of non-ads versions with negligible effect size. We found that the users are more concerned about the battery cost of ads and tend to be insensitive to ad data traffic costs. Thank you for listening.